Today we're going to solve LeetCode question number 133, clone graph. Given a reference of a node in a connected undirected graph, return a deep copy or clone of the graph. Each node in the graph contains a value integer and a list containing a list of nodes of its neighbors. Okay, so this is the node object. So it says good format simplicity, each node's value is the same as the node's index. For example, the first node with val equals 1 and the second node with val equals 2 and so on. The graph is represented in this case using an adjacency list. Okay, so graph is represented with an adjacency list here. Given node will always be the first node with val equals 1. You must return the copy of the given node as a reference to the clone graph. Okay, so basically this is saying that we need to create an entirely new graph that's exactly the same as the original graph, but we cannot reference the same nodes or same adjacency list in the new graph here. Okay, we cannot have the same reference. Okay, so how do we do this? So it sounds easy enough. So in the function we're given a node, and this node will have it into value and neighbors. So for that node, we create a new node. Easy enough, okay? And this new node will have it's node of val. Okay, this is how we initialize the new node object. And now for this new node object, we initialized val. Now we need to populate its neighbors. How do we do that? Well, we can try is for the original node here, what we can try is for the original node's list of neighbors, similarly make new node copies and populate them in new node's neighbors list. Okay, sounds easy enough. So we've done like one here. What if we're moving on? We're creating a 2 here, okay, and we do the same thing, create a new node and populate 2's adjacency list with its neighbors, okay, like this, like this, like this. But problem is we already created a node that represented this one node here, okay, but we're creating another one to populate 2's adjacency list. We shouldn't do that. We should reference that newly created node for 1 in newly created 2's adjacency list. Okay, we can't create a new one. Okay, so how do we do that? How do we keep track of the original nodes and the newly created nodes? Well, we can use a dictionary or a hash map where the key is going to be the original node and the value is going to be the newly created node. Okay, so basically if we created a node for 1 here already and we looked at the original one's neighbors, what we have to do is for each neighbor of 1, check if a new node for it exists already in the dictionary here. Okay, if it doesn't, we have to create it and also store it in this dictionary here. We have to create it and have it be in 1's new neighbors adjacency list. Okay, so that's how we're going to keep track. So every time we create a new node, we insert the original node and the new node in a dictionary here. And while we're populating its adjacency list neighbors, we have to first check if the node and neighbors already exist in dictionary. If it does, then we already created a new node for it and we put that new node in the adjacency list. Otherwise, you have to create another new node for it. Okay, so and the best way to do that is we're doing this kind of same operation over and over. We're going to do this recursively using a depth first search. Okay, and the runtime is going to be O of n because we're visiting each node in the graph only once. Okay, now to code it up, so I want to cover our edge case first. So if node is none, then just simply return none. The graph does not exist. Okay. Otherwise, we're gonna define our helper function, and it's gonna be recursive. Oh, and before we do that, I should initialize the dictionary here. Okay, it's going to keep track of original and deep copy pairs. Okay, now that we have that, we're going to define our recursive helper function here, and what is going to be our base case? I'll define that later, but first let's do the main logic of creating a new node. So new node is going to be equal to the node object and node.val, okay? And obviously we're going to add map the node to this new node here into the dictionary. So dictionary node equal to new node. Okay, great. And now we have our new node list equal to new node dot neighbors. Okay. Now I'm going to reference this new node list here in our for loop for I in node dot neighbors. So for each node in node dot neighbors, what we want to do is recursively call a helper and populate this new node list. So new node list dot end helper I. Okay. And finally, what we're going to do is return new node. Okay. So basically, we have this new node creation stuff down. What is it? Now we're going to go back to our base case. So what is our base case? So basically, if this I already exists in our dictionary here, we want to catch that and return it. And return it in our function call so that this newly recreated node goes in our new node adjacency list. So this is going to be our base case. So if node in dictionary return dictionary node. Okay. So if the node already exists in dictionary, return it, and then it gets returned here and appended to our new node list. Okay, and finally, once this new node creation is done, we return new node. Okay, and then now call it here. And yeah, should be it. I'll try compiling it. Okay. And submitting. Okay, great. Thanks for watching.